have. All right. With that, shall we officially start?
Morning, everyone. Real quick before we begin, let's chat. We're keeping an eye on Twitter during the talk. Try to use it for Q&A if people are tweeting. If not, then we'll do Q&A the old-fashioned way. But please, feel free to use the hashtags. Hopefully you've all seen the TechEd Europe 13 one, and we made up the UCO one, because that's what we're talking about today. Although we did soft introductions, allow us to introduce ourselves a bit more formally. So, I'm Alex Edelsberg. This is my colleague Albert Koyman. This is where we're from. And these are our pictures in the Microsoft directory.
Let's actually explain a little bit who we are and what we are doing. I do not know how many of you actually attended the first session that I spoke earlier on Wednesday. All right, that's about half of it. So let me actually repeat a few things. The one thing that I repeated was that we went from a very Windows-centric world to a world that effectively is now 50-50 between mobile devices and those Windows devices. So about 2 years ago, or actually 3 years ago, because we did an early prototype, we came to the realization that we really fundamentally need to rethink on how our communication service is going to be architected and how APIs work with that platform. With other words, there is a transition going on from .NET APIs to something else. And we started to look into what can that something else be. And we came up with this, what we now call the Unified Communications Web API. The reason why we call it Unified Communications and not Lync Web API is because actually it is used by all the major servers. So if you're talking about Exchange, if you're talking about SharePoint, wherever you need communications, you actually have to connect to us through that web API. And a common misunderstanding, not of course with intelligent people like you, is that if you call it a web API, that people think you have to do it in the browser. But that is actually not the case. What we are trying to say is that what goes over the wire is effectively HTTP. And that is the interesting part. How can you actually use HTTP in order to do real-time communications? 3 years ago, no one had done that before. And we effectively were on a journey where we are literally finding out every day what are the limitations in turning real-time communications in pure HTTP requests. So the presentation today is very much about explaining how we are doing that. Now, I do not know how many of you are familiar with unified communications or with communications in general. But I do want to repeat what I said last Wednesday, that if you think about communications, you have to think about it in multiple dimensions. The first dimension has to do with identity and authentication. It has actually nothing or nothing much to do with communications by itself, but it's absolutely critical. If you want to talk to someone, you need to find someone. And if you want to find someone, you actually need to encrypt it. And if you need to encrypt it, you need effectively that whole web infrastructure. So when you are talking about this API, you will see that a lot of the troubleshooting is essentially around that infrastructure. We originally wanted to present ourselves by actually just retrieving our details from the web infrastructure, but then it turned out to be that there is somewhere on the way, there is this reverse proxy that is not letting things through in the way that we... With other words, there is a lot of stuff around that. I also explained last Wednesday, it's very much about the phone book. What I mentioned was that there is a transition going on where we used to have the fixed network, already 100 years old or 100 plus years old, and then we went into the mobile network. And now there is this telecommunications network that's being built, among others, by Microsoft. Microsoft is building effectively an over-the-top network. So if you are talking about Skype, Lync, effectively the communications that we are offering, the whole purpose of it is to essentially embed communications in every software, and it runs over that data network. So first thing, when we're talking about unified communications, has to do with this whole infrastructure around identity and looking for people. So the Facebooks of the world, the Googles of the world, and the Microsofts of the world, they have those large directories. 340 million users on Skype, 100 million users, even more actually on Lync. So those are the people that you actually can find within our network. And now everyone is switching to the Microsoft account. That's another 300 million people who have a Microsoft account. And with Windows 8, it will be more and more and more. Second part that you need is signaling. So whenever you start establishing, and we will come back to that in great detail when we start explaining our API, you effectively have the way of how to do that handshake between the parties that are involved in that communication. And that is what the UC Web API is all about, at this very moment at least. It is a signaling abstraction of real-time communications. So all the concepts that you might have known from SIP are now translated in HTTP, and you will see that in a moment. And what is then actually communicated is in that payload, is what you need in your code to effectively extract and inspect and act on. But it's a signaling protocol. The third part, and that's the most interesting part at this point in time because it's the most exciting battleground in standards world, is around media. So with other words, once you have established that you want to talk to each other, you need to effectively be able to talk to each other in the same codec, the same encoding of your media. And in that context, you can effectively follow the news around WebRTC. And in WebRTC, there is this discussion about what codec could we use? And Google is saying, well, let's use VP8 and now VP9, and it's all going to be royalty-free, et cetera, et cetera. Whereas our world, the people who are using Lync, the people who are using Skype, they're on different codecs. So there's a whole battle going on about that. But nevertheless, to set the stage, remember when we are going into this presentation, there are three things. There's the whole part around identity and auth, there's the part around signaling, and there's the part around media. So with that, I'm going to hand it off to Alex again.
Thank you, Albert. And thank you for the first person who tweeted. I see we're already getting some engagement. So let's move on to talking about and looking at some of the code. And actually, if you have your machines, you guys can follow along with this and check out our interactive demo. How many of you have seen this website before? We got a couple people.
Write it down, ucwa.lync.com.
We made it nice and easy. Another question, how many people have used UCWeb before? Got a couple people.
Oh, that's very few.
How many people have 2013? How many people are using a mobile client for 2013? You're all using UCWeb, just so you know. We bet the farm on this. We built all of our clients. That's why we have these Apple devices, just to make a point. Let's move on to the interactive demo. So this is nice because we can show everything off. You get a nice experience of what's going on. This is all real code going on. We'll actually be able to dive into it a bit more in a minute. Just going a little slow.
And this is Microsoft, of course. Before you start looking at the code, you need to sign a EULA. The reason for this is actually that there is a server that is powering this that essentially connects every one developer that is on this server at the same time to talk to each other. You have to do some tricky stuff to find out who was online, but that's the reason why there is this. And if you press OK, then you finally get into the server. Now what happens here is because we cannot actually have you sign in all as your individual, because we simply cannot. We have about 3,000 people use this per every month, 3,000 new people. Imagine that I have to provide you all with a password. So what we are doing now is we actually are using something which is called the anonymous login. If you're using OCS or Lync, you have the meetings, and in the meetings you actually are logging in as sometimes as a guest, and that guest login is essentially what we are using here. And we are checking out now, if you go one step further in the demo, we are checking out 3 tokens. We call them web tickets, and those web tickets effectively give you 8 hours of access to that server. And it means that if you are writing your own code, you don't need to set up your server. You effectively, at the end of the demo, will be able to retrieve the strings that those web tickets represent as your identity for these 3 users, and you can start coding.
So basically, if you don't have access to 2013 or your 2013 server at work is locked down, we're giving you access to 3 accounts on a server we're running for 8 hours. So you go through the demo, we introduce you to the 3 people that you have. Apparently I have Amy in Paris, Fernando in Puerto Rico, and Sarah in San Francisco. So we go on and we're seeing you can go ahead and change your presence or status note. And again, this is purely in the browser. Notice I'm doing it in Chrome, not in IE. There's no ActiveX. There's no plugins here. This is just pure browser-based unified communications. And that protocol that Albert was talking about, those wire traces, if we go ahead in any browser, F12, or look for the developer tools, we can actually watch these changes happen on the wire. So if I change my presence from available to busy, we all know it's going to turn red. You might think that it's just saying, hey, make that bar over there red. But if you look, we'll actually see the communication going up to the server. So if we go ahead, we'll see that there is a post on something called presence. The response code coming back is 204. If you know HTTP, you know 200s, anything between 2 and 300 is a success. In this case, 204 means no content. If we go ahead and look at presence and look at the request we sent out, we said, please set our availability to busy. It's turned red. If we go look at this event response, which we have gotten from somewhere. Oh, no, we missed it by one. I should have opened it sooner. But anyway, we see that the presence has changed. And even if you weren't looking at developer toolbar, you can go ahead and look at this command here. Anyone familiar with curl? For those of you who aren't, it basically does HTTP requests and responses directly from the command line. Nice, easy way to get started. I wouldn't recommend writing anything real in it, but this gives you an idea of what's going on. So we say go ahead, use curl, issue a post to this URL, send the body, availability is busy. The content type of the request is JSON. I would like JSON back if you're going to tell me anything. And then for authorization, please send the web ticket, the token that Albert was referring to before.
So though it's important to actually know what the traces are that are going back between the server and the actual client that you're writing, the abstraction of it in HTTP is the most important thing, right? So we are effectively taking away all the complexity of writing that signaling protocol by providing you with a very easy way to actually do that. And by the way, if you set, for example, the status node here, you can actually see that it's not only the presence that you can change, but now here you can see that the message that actually goes, that payload that goes over that wire is effectively what is that message that needs to be changed. So it's a very easy, effective start of it.
Anyone? Oh, we have a question.
In your session Wednesday, you showed a program that actually also changed the name of the thing. So you can do that from that?
So the question was, on Wednesday I showed some UCMA code that essentially allowed you to define custom presence strings. Our current API does not support it yet, so that's why you saw effectively a drop down from busy, etc. However, I'm very sure that those custom presence states will, as soon as we enrich the API, those will come back. The one thing, however, that we need to realize is what I actually advertised there is that the UC Managed API allows you to effectively define any present state at any point in time. We think that in order to make this very scalable, like effectively we are building a Lync server for 1 billion users, right? Because if you want to become essentially a telecom network, you need a lot of... We actually are going to make sure that we have it a little bit more restricted than that everyone can do anything at any point in time. By the way, this question is also very much a reflection of, Alex just a moment ago said, hey, this API is being used by all our mobile clients, and I said just a second ago, our API only supports busy available and those type of things. Therefore, custom presence states actually at this very moment don't show up on the mobile client yet. So that's just make this correlation, right? So.
On the bright side, though, the web API can view custom presence if set somewhere else. It just cannot set them itself. Okay. That does work. So you have part of it today. Any other questions before we go on?
Okay.
All right. So we go through again the interactive demo. You can subscribe to the presence of others. So what this basically is just like you say, you know, I want to know when someone becomes available, and you get the little toast as soon as they change their presence. You can do the same thing in the web API programmatically to then light up that experience in whatever UI you are generating. So we go ahead and start a subscription. We have the top view of Amy's Lync client, so you can see where she can set her note, she can set her presence, and Fernando has Amy on his buddy list. So if I go ahead and make the changes here, you'll see them reflected here.
Now, this is actually optimized for mobile use, right? So, and one of the first things that we found out is that when we generate our APIs for the mobile wave 1, that it sucked your battery empty within no time. So therefore, we are effectively now using a different protocol than we did in mobile wave 1 when we switched to UCWA that essentially only does the things in a very, very efficient way with regards to not only the messages that are sent back and forth, but also the amount of updates that it's doing. For example, here you only have 2 people on your buddy list, but if you're on a mobile device and you have, let's say, like myself, I've got about 500 people in my buddy list, I'm not going to retrieve all 500 of them, but only what is visible in my screen. And if I actually start scrolling, then it's actually what is happening is then I start retrieving the rest of that buddy list. So those type of optimizations have been made in the API as well.
We call the concept Albert's referring to UI virtualization. So the idea being, this is the 5 contacts visible on my phone. This is the approximate length of my buddy list. Albert's probably hits the ceiling. And only at that moment when you scroll do you say, now I want to know about the presence of the people that were not on screen before and are now. And again, this is a little contrived because we're all within one window, but I don't know if you noticed there was a bit of a delay, and that was actually the time it took for the presence change on Amy's side to make it up to the server, and then the server to inform Fernando on his side that the presence changed. Again, we can see this a bit more realistically when we're in another setting, but I do promise that there is server traffic going on here.
And it's very different from the SIP messaging where everything was all the time like, hello, here I am, okay, thank you, bye, hello, and this constant talking back and forth effectively makes your battery goes empty. All right, next one.
The next one we have here is instant messaging. This isn't just for viewing. You can actually interact with other people. And again, a little contrived. They're both in the same window, but I do promise there's server traffic. If you don't believe me, you can keep me honest and we can watch here. So again, you see that some of these things, events are coming back and forth. So you can actually, if we go ahead and look at one of these, we'll get a bit more into this later. You can actually see there's a conversation that happened. Let's see if there's anything else we can see here. So it's a little bit hard to read. So we see if there's an outgoing message. We have a timestamp for it. We might have the text if I go to the right spot, but I don't know where it is. This is a little hard to read. We'll have slides that show this in a bit of a neater way. But you can see the IMs are actually going back and forth. There is traffic going between the server, but the requests are pretty simple. You saw you had a conversation. You had a message. The concepts are straightforward. As Albert said, it's less chatty than SIP and a bit easier to read. Go ahead and see the message comes through again to the other side. And you can see again, if you want to generate this in curl, we pass the command here. And you see the message is actually part of the payload. If we go ahead from there, this one we're not going to be able to do because we are not in the US right now, and I don't want to pay for the long distance call. But we do support phone audio or call via work as well. So if I do this, what will happen is the number that you enter will ring, and it will connect you to another number. In this case, we have a bot living on the server that will play a message saying, hello, thanks for using UCWA, and you can actually see that phone modality going through.
And given the fact that this is the number one question that I always get asked, when do we get media in this UC Web API, because all your mobile phones can do it now, why can't we get it as developers? Well, just like we have in UCWA, we've got an internal namespace. Indeed, here we have got also an internal namespace. And that internal namespace, only once we are ready with it, we will actually make it possible for you to use it as well. The plumbing is there, the documentation is not there yet. So consider this a roadmap item.
Yeah, so when we tell you it's coming, it's not it's coming, it doesn't exist. You're already using it today on your mobile clients. It's just not quite ready for public use yet.
And this demo that you see here, this dial pad that you have, is you actually can enter your phone number and it calls you back on your ordinary PSTN phone. So everything in CU2 that is coming out on July 1st, that is our cumulative update. You actually also have capabilities like, for example, transfer calls. So you can actually, as long as it's connecting then to the PSTN, you can actually transfer your calls to the PSTN. And this one is just calling you back on the number that you enter. But like Alex said, it only works in the United States. All right, and with that, this was the very first thing. Now, if you close this, I spoke about that you are able to get tokens. And these are the tokens that you actually can embed in your code, and then in your code, you actually can start logging into that server that we have as our developer download.
And so as you can see, for the 3 people that we had before, we have Amy, Fernando, and Sarah, and for each one of them, we're getting a token. So Amy's token, as far as the server is concerned, you become Amy for the next 8 hours if you use that. And this is actually a little sneaky trick we came up with that lets us give you access to the accounts without having to give out passwords and then changing them after 8 hours. Because once these expire, without a password, you can't get a new one. But if you need a new one after 8 hours, go through the demo again. You can actually skip the demo and go straight here, and you'll have tokens to play with again. So here we also have the instructions to go ahead and download and extract the samples and run the samples. How many people are using Windows machines? How many people are using Macs? Okay, I use one too. Linux, anyone? Mac and Linux guys, I have good news for you. These samples work just fine on both of those platforms as well. You don't even have to be using IIS. Works on Apache, works on Nginx. This is pure HTML and JavaScript. Shall we go ahead and show them now?
Yeah, go ahead.
All right. So
the call to action is actually to download these libraries. How do you want to get started with UCWA? Now, in order to make life easy, we actually started implementing those libraries that I spoke about that we would love to actually engage the community with. And those libraries, there are a few restrictions to it when you start running them, because as they are implemented, they are only implemented to actually download the zip, you can deploy them on your web server. But the one thing that I want to warn you for is don't change the port, because it only works with port 80. So if you think, oh, let's put this website on another thing. The other thing which it does is it can only run on local host. And that is because that server that we have only trusts the local host. And that's because we are using cross-domain scripting. And therefore, if you do cross-domain scripting, in order to use UCWA in a web browser, you need to define what are the other sites that you trust. And again, in order to alleviate our overhead in trying to provide you with customized websites everywhere, localhost was the common denominator. So Alex just unzipped the stuff and put it in his IIS root, I think.
Yep, so I just followed steps 1 and 2. In this case, I have IIS already installed. If you have Windows 8, I think for most of the SKUs, you can actually just go ahead and add IIS. I added it beforehand. Drag the samples into a folder under IIS, in this case called TE13. So if I go there, you go ahead and get into the samples. And you see it asks, how would you like to log in? In this case, I'm trying to log in from the developer sandbox, which is where we are now. And it says you've got your credentials here. So if we go, it says enter a domain and token. If we read the instructions, it says access the files from your browser, click on the developer sandbox, enter the domain .uc.net without quotes. Go ahead and copy one of the OAuth tokens, including the word bear under the token field. So I'll take Amy. Go ahead and paste in her token. Click login. Wait a couple seconds for the login to go through. And I'm now logged in. You can select a module or a task for more information. So the modules we have here describe the key building blocks that we believe any application will need. Because this is HTTP based, every single application is going to have to be able to send and receive HTTP requests. We have a module for that called transport. And this gives you some detail about how transport works and how to use it. If you want to see using transport to actually get a task done, you can go ahead and do things here such as getting your presence, setting your presence, and if you want to see those presence updates, you click Start. You'll see away. If I change it to busy, click Set Presence, a few seconds later the message will come back down the wire. So that interactive demo that you saw, you can actually follow along right now, download the samples, get some credentials, and play around. If you open in two different browsers, you can actually go down to the sending an instant message back and forth. From here, I would like to transition back to talking a bit about what's going on at a higher level. Hopefully seeing what we can do has given you, has whetted your appetite a little bit. So the big concepts here, as Albert said, is this is all going over HTTP. The other big thing, at least for right now, is JavaScript. We picked JavaScript because it allows us to run cross-browser, cross-platform. I'm happy to say with the very first sample set that we released in one programming language, we're able to run on Windows, Mac, Linux. The samples will even load up on an iPad browser if you point it at the website. So JavaScript is big right now, but there's nothing stopping you from writing UCO applications in other languages. As you can imagine, our iOS and iPad clients are written in Objective-C. I've written some toy Python scripts just to show how it might be done. Windows Phone probably has some C# and .NET in it. No one's done PHP yet, but there's no reason it can't be done because PHP actually uses curl underneath to issue HTTP requests and responses.
The interesting part, what I mentioned just a moment ago about this local host to be the trusted site. Of course, if you write an abstraction library in .NET or in C# or in Objective-C or Java, this whole thing about a trusted site goes away, right? Because you are not doing cross-domain scripting. So if you actually do want to run applications without those restrictions, you actually are able to write mobile applications already that run against the server.
Before we go on, how many people know what cross-domain scripting is? Albert and I have used it a couple times. Got a couple hands. For those of you who do not know, if you're actually on ucwa.lync.com, we have some good explanations about what that means. But basically, if you grab the samples, they take care of most of the work for you. So a bit more about the design philosophy behind this. As Albert said, it let us rethink UC clients. Has anyone had the opportunity to use the 2013 clients on 2 different devices, on an Android, on Windows Phone? Okay, a few people have. Pretty uniform experience, right? Despite being on different devices. Things kind of look the same, things kind of behave the same. Nods? No? Yes? One of the reasons that we're able to get an experience like that is that with UCWA, the web API, we are actually able to keep more of the business logic on the server. Presence is controlled in a simple way. There's a set of valid presence values, and we take care of propagating it out and informing other clients on your behalf. Going ahead and looking at other people's presence, going ahead and receiving IMs. We take care of the endpoint management, most active endpoint. So the client teams are able to focus on providing the best experience on their OS, whereas the Lync experience, more of that logic is pushed up to the server than there was before. This results in thinner clients. They're easier to maintain. And actually, it allows the clients to focus on innovating on what they're doing while we can innovate on the Lync experience.
And also, by the way, for Microsoft, this makes life a lot easier because in the past, you essentially had for every OS a team writing the business rules again and again and again on different platforms. If you, however, deal with things like, okay, which device is active, where do I need to send this IM to, if you things like the timeouts and etc., all the business rules that are built in the past inside the client are actually now moving from the client into the server. And actually, just as a roadmap, just to put this ahead, right? So if you are talking about the whole transition that Lync is in or that Skype is in, we are effectively making that server side more and more accessible through these HTTP APIs. So currently the UCWA is very much a client API, but you can imagine that everything that you can do through the managed API, which is a server-side API, will be effectively abstracted away as well in those HTTP requests.
So we keep talking about HTTP, and you got to see the basics, the browser, and some responses coming back from the server. Let's drill down a little bit and actually look in some more detail what's going on. So on the right-hand side, we have yourawesomesite.com. This could be helpdesk.contoso.com. Could be something else. And on the right-hand side, we actually have contoso.com with a Lync server. So within the Lync server, we've broken out some of the relevant boxes. You can see we have a line represented that's breaking away the API from the rest of the internals of the Lync server. So the API your exposure, again, is just HTTP. It's requests and responses. And then underneath, we boil down into some of the actual layers within the server. You can see there's that web ticket service that Albert was referring to before. That's what issues and verifies your credentials. You can see there's UCWA, which was actually written on top of UCMA. You see there's a discovery service. This is used for actually locating your home server. Given your credentials, it will actually route you, if you're hybrid deployment online and on-prem, or if you have multiple on-prem servers, it'll route you to the right place. There's other web components that we're going to leave out just for complexity's sake. You've got the focus of the MCU that actually handle the media. So when you're using our clients, that's what you see. Underneath, you have the SIP proxy, the RTC database, and the rest of the components of Lync server. So as your first step, your application would hit the discovery service. And if you're doing a browser-based application, which we're focusing on, again, today because our samples are in JavaScript, the first thing you will actually do is go to linkdiscover.domain/xframe. And we make a promise that if you're hitting a properly configured 2013 CU1 or later server, you will get back a frame that is hosted by that server. And this is an important detail for that cross-domain scripting problem we were talking about before. The basic idea is to prevent security holes in browsers, HTTP requests cannot be issued from yourawesomesite.com to contoso.com. If they were, you could be logged into your bank in one tab, go to a forum in another tab, and some guy's forum signature could try to issue an HTTP post to your bank that says transfer $100 from my account to the malicious user's account. You don't want that to happen, so browsers have prevented that. There is a safe and allowed workaround that goes through this cross-domain frame. So you'll go ahead, as I said, and download the frame. And then all subsequent requests will be routed through it. So in your web page, as it's showing here, you have your business logic, you have our JavaScript helper libraries today, and now you've actually loaded the frame into the DOM. All subsequent requests will be routed through it, and that transport layer I was talking about before will take care of it for you. So after that, you will go to the discovery service, say who you are, and you will get routed to the web ticket service to provide your credentials and actually verify your identity. Once you receive the web ticket, the OAuth token, the same ones that we saw on the demo site before, you'll be able to proceed as an authenticated user and go ahead and make subsequent requests to UCWA, do those presence updates, start sending messages and everything else. In the case of, oh, I skipped a couple arrows, I apologize. So that's the authentication step, and there's your actual UCWA communication. The last piece to think about is how we handle those real-time updates. I was saying before that you can actually get presence notifications for people and it's less chatty. We do that with something that we call the event channel. We'll talk about that a little bit more later, but it's a separate line of communication just for those important real-time updates. So if your client is sitting there idling and you get an incoming IM, that first incoming, well actually all subsequent as well, incoming IMs will come via that event channel. So let's drill down into the UCWA specific parts and abstract a bit of this away. So as Albert said before, the UCWA API is represented here by the two lines between your app and the Lync server. There's the command channel where you're issuing your requests and that event channel where you're getting real-time updates. The HTTP requests and responses and the payloads that are moving back and forth, that is the API. Everything else is an abstraction on top of it. The JavaScript samples that we give out, the libraries that the mobile clients are using, those are all abstractions on top of it. If you need to debug, if you need to understand, you need to be looking at the wire. So the command channel, as it says, is HTTP based. We have 4 verbs to keep things nice and easy: get, post, put, and delete. Does anyone know the acronym CRUD? Database acronym stands for create, read, update, and delete. So get is read, post is typically create, put is typically update, and delete happily maps to delete. This is how you make your requests to the server and receive your responses. In the case of presence, if you want to read someone's presence, it is actually as simple as doing a get on their presence, and you will get it back. If you want to go ahead and update your own presence, create a new presence, if you will use the post verb on the presence resource, and you will have set your presence.
And effectively, like when I said, hey, we had to rethink unified communications or real-time communications into HTTP things, this is what is the outcome, right? So everything that you as a developer want to do actively, where you actually have your rules of your app, define it, it is going through that top line. However, everything that effectively needs to come from the server to let you know what has happened on the other side, that's effectively, we open this socket and then there needs to be coming something back via that event channel. So this is the innovation that essentially took place in order to make real-time communications possible over HTTP. The event channel is therefore very much essentially just an open line, a pending get, I would say, right? Mm-hmm. And in that pending get, you will actually get then the results whenever you need it to be done, as soon as the server decides to do that. Whereas via the command channel, I would say actually you as a programmer decide what to do.
Exactly. So as Albert said, the event channel is asynchronous. It is a messaging, it is a way for the server to inform you of changes that are going on. And the way that we do it is using something called a pending get. For those of you familiar with HTTP, you know that it's typically synchronous. This is a way to allow us to get some of that asynchronous behavior without having to use a different protocol. And what effectively happens is the browser, your code will tell the browser to issue a request to the event channel. And instead of the server immediately saying, I have your request, here's a response, take your data, the server goes, I have your request. And doesn't send any data back right away. Turns out that this is perfectly okay. The browser will happily wait. So what we do is we purposely leave the connection open until something important happens. So there's actually different priorities for events in the event channel. So an incoming IM is considered the most urgent, a real-time event. You have to know about this right away. So as soon as an incoming IM comes in, the server, with its own logic, your client doesn't have to do anything, will say, this is the most important type of event there is, and push it down, and you'll receive a response right then, and your app can react to the incoming IM. Things like presence updates are considered not quite as important, so it's actually possible you get 2 presence updates, nothing will happen for a little bit, and then when that incoming IM comes in, that'll be the trigger to push all 3 messages down, and they'll come down together in a single event response.
And let me add to that actually another perspective that is very important to understand once you start programming this, and also when you actually use our mobile clients. One of the things, for example, if you are working in a mobile environment, is that you do not know, especially in the United States, which is like a developing country in this whole mobile space, right? It's not like Europe, so that's why I have to put this. But you never know whether that network is working or not. So you actually, if you're listening to Alex, with regards to the present state, you do not know if that user has been connected. So in that sense, that when you are effectively now going into the mobile client and you will try to contact someone, very often you will find that in the mobile clients, the present state of the user is actually away. And away in this particular time, actually, of the real-time communications over HTTP, over those crappy networks, essentially doesn't mean that the person is away. But essentially we have set it as the default state as, I actually do not know, and I did not want to drain your battery, so click me, and then I will actually check again. And then you will see, literally, when you click on that name, you will see the present state really make an active request to the server, update the present state, and all of a sudden it turns green or red or whatever it is. But what used to be effectively you're not connected and you're going to gray to offline is actually no longer offline. The essential state now is away if you're talking about those mobile clients. So just to keep in mind. So there is, and by the way, that we are under the hood taking care of, okay, hey, this person has not reported to us for quite a long time, etc. And when a message is being sent, that sometimes that we need to send it again in order to actually make the connection to the right endpoint, that's all done by the server. And that's all done by effectively the API implementation inside Lync.
That's another example of what Albert and I were talking about before, where the logic is now being pushed up to the server. In this case, with questionable mobile connections, it's actually a necessity, because if the client has a bad connection, it can't tell the server to change its presence. So when we keep talking about, changing your presence, sending an IM, you're communicating somehow over HTTP with something on the server side. And the way to think about that something is going back to the browser. If I went on my browser and I type in bing.com, I get back a web page. If we abstract that away a little bit, if you type in a URL into your browser, you get back something. More abstractly, if you've read the HTTP RFC, I have many times in working on this project, or if you're familiar with Roy Fielding, he's very influential in the REST community. He abstracts away the page concept into something called a resource, saying that it does not have to be a web page. It does not have to be a URL as we know it. So in UC what you're actually doing is you have a URL that somehow points to a presence resource. And if you're looking at your presence resource, there's a few verbs you can use on it that we spoke about before. If you get your presence resource, you'll get back a representation of your presence as the server currently understands it. If you go ahead and post on the presence resource, you're creating or changing your presence. So you're making these changes across the command channel to a resource. And if there is a change to a resource that we deem important, such as an incoming IM resource was created by someone else for you, that resource is sent back on the event channel. So the atomic unit that you need to think about this API in is the resource. And I would say a resource is most analogous in the .NET world to an instance of a class. It's not quite the same, but that might be a good starting point.
Maybe actually you would show the presence graph or the API graph at this point in time, because this whole concept of resources, I felt it was very, very difficult. And also, if you know that this is an API that is effectively being written while you start using it, right? So I'm not saying that it's not written yet, but we are evolving this like crazy. You therefore cannot define an API as a static thing. So the concept of these resources is extremely important, and also that resources can change from one version to the other and effectively have to be queried actively is what we try to essentially reflect in an API explorer that we have implemented on this usiwa.lync.com website.
Now, before I go to the explorer, Albert just said this API is changing a lot. How many developers in the room are excited to hear that we're asking you to write on an API that's changing a lot? Please don't raise your hand, because I'm not excited either. I do have really good news, though. The API has been changing since we built it. It evolved from a prototype into the product that we've released today to power our mobile clients and that we are offering to developers to build their own solutions. Despite the fact that the API has been changing often, we've actually been able to independently version our clients and our servers without the changes impacting one another. Part of the graph in the API Explorer that Albert is referring to is a visual representation of how you're able to decouple these two. I'll skip these slides, and I will cut to the Graph Explorer. Go back here. So this is available on usiwa.lync.com. It might be a little slow, so I'll try and load it. But in case it's going slow, I may load a local copy just to so you guys can see what it's like.
Essentially here we have got a JavaScript graph. Here we go.
So if you go ahead and create, you are writing an application in the browser or on whatever device you're writing it on. The server has to somehow be made aware of your application communicating with it. So what we actually have you do is we have you create a resource called application that is how you tell the server about your application. So if we go ahead and look at the application resource, this could take a second to load, you'll see that there are some properties that get set. There's a culture, which is culture and locale, so in my case it would be ENUS. Obviously it depends on where your app is running. And you also have a user agent for your application. This is a unique name for your app so it doesn't collide with someone else's app. And this is how you register your application with its unique properties with the server. Now, you have an application, and your application wants to know what it is capable of doing. In this particular case, the way that we handle that is that we have links coming off of each resource. So you know that your app can do something called batching. Your app can do something called events, which is the event channel we spoke about before. Your app can do something involving policies. Your app can do something involving communication. The nice part about this hypermedia concept is that if your app, for whatever reason, does not have permissions to do something, it's very easy to tell. The link to that resource will not be there. If the link is not there, don't light up the UI for that particular
so when I described earlier that, so we have this public namespace and there is an internal namespace. If you would have loaded the internal namespace, all of a sudden this graph would show all the other things that would be available if you would be having a documentation of that internal namespace. So that is how we, essentially, you create your application and you have the namespace that you actually are allowed to do, and then these are the resources that show up. So when, for example, call transfer shows up, now in CU2, it's just one extra thingy that drops off of, I think it's of communications at that point in time.
Mm-hmm. So if you look here off communication in the public API, you see that we've got access to joining an online meeting, messaging, starting your own online meeting, and starting phone audio. As Albert said, if you were looking at the private namespace, there would simply be more links. If, for example, one of our mobile clients accidentally hit a server that didn't have the full capabilities, the start a video call button would simply not light up because they're not seeing the link. What this actually allows us to do as well is the mobile clients started to prototype new features against servers, and if they hit an older server that didn't have a new feature they were trying, the client didn't crash because it didn't see a link. The client simply said the link is not present. I won't light up that bit of my UI. Same goes the other way. If we implemented a new feature and the clients weren't ready to consume it yet during our development process, they simply ignored links they didn't understand. And so despite the fact that the API is still rapidly evolving, we are able, and we have been doing for the last few years, this loose coupling between clients and servers. Like I said, this graph is publicly available on the website, so you can get a visual feel for how these resources are interconnected. This visual we find really helps because writing an application in the web API is as simple as walking this graph. So from my application, I want to go send an IM. Communication seems like the right place to go. We take a look at the communication resource and we see something called start messaging. Turns out that start messaging does exactly what you think it does. It allows you to start a new messaging conversation with someone else. If we go look at how to use it, we see it only supports post. It says it starts a messaging invitation that adds the instant messaging modality to a new conversation. If we want to understand how to use it, we can see what query parameters it takes. It takes a 2, which is the target. You can look at the request body, and we see that we have some more information here. So you can imagine, in a nutshell, to send an IM, I issue a post to the start messaging resource, and we see that the only required thing is 2, to say, who are you trying to IM? So if I post on this and I say to sip:@contoso.com, it does exactly what you might think. It attempts to start a new IM conversation with alex@contoso.com. And like we said before, this is how you'll walk the graph once you've created your application. It's a simple question of finding the links to reach the task that you want to do, and then actually issuing the correct command to start the task. What will happen here is we'll create a messaging invitation, as it said in the description, and when it loads, we'll see that we also describe what happens on the event channel. You can see that there's a started event, an updated event, and a completed event, and we give a bit of detail about what those look like.
And don't get scared, because this is exactly what the libraries do, right? So if you want to say, okay, I would like to program at a more higher level, those libraries will actually help you. But if you're then looking what is going over the wire, you actually can find it over here.
Mm-hmm. So let me go back to the presentation.
And by the way, so can we get back to the previous one?
Okay.
So those libraries that we have, we currently only have JavaScript libraries published, but anyone who would be willing to help us with, for example, C# library for doing some stuff on Windows, or a Java library to do stuff on Android, I really would love to actually collaborate on that and make sure that we create the right helper libraries and take away a lot of this effort. Because once you have written this, you actually can very quickly, more quickly, you can build your own applications on any OS and build communications of Lync straight into your own app.
We did our best when designing the samples to be diligent. We were very careful in talking about them as helper libraries. We tried to build exemplary components that make sense regardless of the programming language you're using. So when we actually write them in JavaScript, we've commented excessively trying to describe the task we're trying to complete independent of the language. So the hope is that by looking at that and having some conversations via Albert with the engineering team, it's actually pretty clear how to do this in other programming languages. Again, we picked JavaScript because it allowed us to get a lot of reach and show some new exciting technology in the browser. So we keep talking about the wire. Let's actually look at the wire. So this is an example of the application resource. We actually call this a rel, a relation type, within our payload. So I wrote at the top that this is the application resource. You can actually see we know this for sure because each resource will tell us what it is. This is a nice little pretty printer of what it looks like. If you've seen JSON before, it's got some curly braces here and there, so this is a slightly cleaned up version. But the concept is the same. You can see that we've got 3 different components within each resource, and this is repeated for every single resource. You have a collection of embedded resources, and this is actually no different from a Lync. What we've done here, though, is, again, mobile and battery life are one of our major concerns. So if certain resources often are used together, we embed one resource within another to save you from having to do a get.
And this is, again, for battery life and for bandwidth and those type of optimizations that we needed for mobile, right? So whatever you can put together, you will put together. And only if there's a compelling reason not to put it together, then you start separating it out. Mm-hmm. That's the base principle on which this is designed.
And really, embedded is no different from a Lync conceptually and even programmatically, except we've gone ahead and done the get for you. So it just saves you some time. So you see below we have some links. We have batch, we have events, again referring to the event channel. We have your policies, and we have a self-link. Every resource has a self-link, so you know the canonical location of that resource. Because as we said before, just as Bing.com points to the Bing web page, the self href will point to this resource, in this case, application. And then you see the culture and the user agent that we set. This one was apparently done by the samples. and it's in English. So this is that instance of a class that I was referring to before in our API. This is a JSON representation of the resource as it exists on the server. How many people are comfortable with JSON? How many people prefer XML? Is there a third option I'm missing? Well, we support both JSON and XML today. If there's another one that you'd really like, get in touch with us and let us know. But we thought that would cover most people. So if you have more experience with one than the other, you simply change your request and say, I'd like to see this in XML, and you could actually get that back. We've been dealing with JSON just because it makes more sense in the browser, but our clients actually, I want to say the iOS ones still use XML. So hypermedia, we actually already spoke about this. This was that linking concept that we saw visually with the graph and that you can see within the payload. I want to talk a little bit more about it though, because there's several other pieces to it. Just as we already spoke about the fact that this is how you navigate, this is how you get tasks done, and this is how you actually light up your UI to know what your user in your client is actually allowed to do. This user's policies say that he's not allowed to do VoIP calls on the mobile clients, and therefore the start VoIP call link will not show up. The other part of it is that the client can actually use these links, these hypermedia links, to understand the relationship between resources and manage things on the client side. For example, if you have a client that has multiple IM conversations going on at once, and you get a message resource that shows the IM that someone just sent, how can you figure out which of the multiple conversations it belongs to? Turns out that every message resource has a link back to the conversation it belongs to. And those links, we have that self link that we saw on the previous slide. So the conversation is a canonical URL. That same URL will appear in the message, and you can actually use that as a key to map things back. So this hypermedia concept is not only important to understand what your client is capable of, it's also useful for managing your state on your side and understanding how the resources are connected.
And this, again, also if you have unreliable networks, right? So this effectively allows us to backtrace of what was happening at what point in time on the server, because it all has that same URL essentially to relate the stuff back.
And if the hypermedia concept seems a little foreign, or you're wondering why we're using the word hypermedia, think of links on a web page. You may see, from Bing, you may see the word images, and if you click it, it takes you to images.bing.com and shows you the image search there. That layer of abstraction, that indirection between the word images and the URL images.bing.com is the hypermedia concept. It's an abstraction, so you can focus on the text, in your case as a human viewing the browser, instead of on the long URLs. In the programmatic side on UCWA, you focus on these links and these relation types instead of focusing on the actual URL and crafting them. A lot of other REST-like APIs focus on, or rely on crafting URLs by hand, so it's effectively string concatenation. It's messy and it's error prone, so that's another nice thing about using this hypermedia concept. So you get independent client server versioning, because if you see a link you don't understand, ignore it. If a link that you wanted isn't there, you simply don't light up your UI. You get the ability to map resources back in unreliable connections, as Albert was saying, and that is why we focus so much on this concept. And again, the graph provides a visual if it's a bit much to wrap your head around at 10:45 in the morning. So the last thing to talk about are the key components, the modules that were referenced on the side. I'm going to pick these two because we keep talking about the command channel and the event channel and issuing requests and responses. So these two modules are the ones that actually power that experience. So if we go ahead and look at the sample site, like I said, it kind of documents them, and we can talk about them while we look. And it describes them at a higher level. It doesn't describe them how they were written in JavaScript. We talk about them at a higher level, kind of giving people a guide for how to implement this in their own programming language if necessary. So the idea of transport at a basic layer is that for every request that you send out to the server, there's a few things you have to do. You have to tell us what URL it is, You have to tell us what verb you want to use, get, post, put, or delete. You have to tell us how would you like to receive the response, today XML or JSON. You need to include your credentials, in this case that web ticket, that OAuth token. So because every request has to do this every time, regardless of language, regardless of what your app is doing, you can't do anything without doing those steps for each request. We said we don't want everyone to have to do that every time, so we built a transport layer that handles all of that for you. You basically provided a set of parameters. You can imagine the bare minimum would be the verb and the URL. We assume JSON because it's JavaScript in this case. You go ahead and issue a request just like that, and we take care of everything else for you. We package it up, we make it a legitimate HTTP request. In the case of JavaScript, we're actually relying on jQuery, not some home-baked Microsoft solution, and we go ahead and issue the request for you. In another programming language, I mentioned PHP before, you might imagine transport.php is a wrapper that takes these inputs for you and then issues the request via curl. In Python, I believe it's called HTTP client. In Ruby, I don't know. If someone knows, they can shout it out. In C#, it's system.net.http client, I think. So you could use HTTP client raw if you're a C# developer, but taking the time to have this transport layer just takes care of some of the necessary things that you would have to do with every single request anyway. The one other thing that happens in transport, which is unique to JavaScript and the browser-based world, is that cross-domain frame. We actually take care of packaging things up and pushing it through the frame on your behalf. In other languages, when you're not in the browser, you don't have to worry about this. That make sense? Any questions? All right, just making sure. The other one to look at would be events. We keep talking about the event channel. So what the events module does at a high level is it keeps what we call the event pump running. And the order is simple, and the task is not that big, but you have to do it in the correct order. You're sitting and waiting for an event channel response. We assume that's already started. So you're waiting for response N, and once you're done, you're going to make a request for the next event channel response, N plus 1. So as soon as you receive event channel response N, the first thing to do is to open it up and look at the response. You'll see a link called next. That tells you what the next event channel response will be. First thing you do is open it up, grab the next rel, grab the URL underneath it, and issue the next get, the pending get. And the get is actually issued by the transport layer, so those two modules are already working together. The next thing that you do is go through the event channel response and look at what was sent. So you'll see, there is a new messaging invitation that has some information in it, for example. The third thing that you will do while looking at these is you will actually dispatch them to the appropriate pieces of your code. So one other thing the event channel can do, or that the event module does, is it lets you register handlers. You could imagine that you have a handle incoming IM piece of code that you wrote, and you have the event module. You tell the event module, if you ever see a messaging invitation, hand it off to this piece of code. And so that's exactly what will happen. As you're reading through the response, you've registered an event handler, we call it. You registered an event handler for messaging invitation, and your code will get executed. Now you could go ahead and have every single different piece of code look at, pass the event back and forth and take a look at everything. But we figured it was easier to have it centralized and say there's a piece of code whose job it is to handle event channel responses. If you're curious about an event channel response, tell it what you want to know about, and it will be responsible for dispatching to you. And we think this is something that will make sense in all languages as well. That make sense? Any questions? Okay. So those are the two key components that we're talking about. There are a lot more here, but everything else kind of builds on top of it. There's discovery to help you find your home server. There's authentication to help handle the trading of credentials for that OAuth token. There's a cache for optimizing certain things that don't change very often. Typically, someone's contact information doesn't change, so you probably don't want to issue requests multiple times. There's also batching, which is an optimization to do multiple requests in one shot. And there's the concept of an operation resource that's referring to those invitations where you'll go ahead and say start messaging, and you'll have a messaging invitation that you want to monitor to know if the other person received it or they were on a bad US mobile network and they didn't receive the incoming IM from you. So next thing to show off is the samples. We've kind of walked through them. I can walk through a little bit more, though, if people want to see. Oops. let's go here, make sure I'm still logged in. I am. And I'm actually going to log back in as someone else. Do you know your .uc password?
Yep.
Okay. Or actually, yes, perfect. So I am logged in as me on a separate topology, and Albert's going to log in as himself, and we're actually going to show an IM real quick going between the desktop client and the JavaScript samples. Now you can see, unlike the interactive demo where it was just the same page on the browser, you're actually seeing the messages. They have to be going back and forth because otherwise the Lync client wouldn't get them.
Or I do not know, actually.
Oh, it didn't work?
Well, let's see if we get challenged.
Give it a shot. Oh, this is the one that doesn't do it.
Alex did not update the samples yet. But
okay, so,
all
good.
right,
So we're logged
I'm in.
So I go to instant messaging sample. And in this case, I'm going to say I want to listen to an incoming IM. I don't think Albert and I are buddies on this server.
Oh,
so that's okay. So we'll say start incoming. And I will find Albert at gotuc.net. Someone say a quick prayer to the demo gods because I have not tried this with this account this morning. Hey, it worked. All right, so we go ahead and we see we have the incoming IM, and after a second the text please work shows up. You see we have a timestamp. We know it's the Alex Edelsberg account that's here on the topology we're using. Can't fake that. We even have some nice downgrading, so the emoticon here will get downgraded back to text, so you won't suddenly have a weird web page crash or a funny symbol showing up in the middle. But there you go. IM between a browser and the desktop client. Notice I'm using Chrome, not IE, so there's no ActiveX, there's no magic going on here. This is just pure HTML and JavaScript, and those are the samples that you watch me download. So if you're following along on your computer right now, you can actually start using this yourself. So,
And by the way, this developer sandbox has Open Federation open, so if you want to test it against your own rich client, it should be able to, of course, if you like if you allow Open Federation, you can send messages back and forth.
So we talk about sending messages back and forth, and we've kind of been talking about the HTTP. This is an actual visual of what's going on. This is, we found our favorite way of displaying this. If you're on Windows, there's a really great tool called Fiddler that can sniff all of your HTTP traffic. We actually talk about it on ucy.lync.com, how to install it and set it up. But this is kind of a visual of what's going on. So when I actually went ahead and sent that message, this is actually the other direction. This is an outgoing IM, but the incoming situation is pretty similar. So I go ahead and issue a post to the href, the URL represented by the start messaging resource. So we followed the link from application to communication to start messaging. And we go ahead and we use it and we issue a post because we're trying to create a new messaging conversation. So we issue a post. You see the accept type is we want JSON back. Our content type outgoing is again JSON. Authorization, bearer, and then our OAuth token. And then we have the host, which you see that the URL is a relative one. It doesn't start with HTTP, so the host is down there. And we sent a few parameters as input here, in this case in a JSON property bag. The importance is normal. The subject is hello roundtable, because I forgot to change this from a roundtable I did a few weeks ago. We're sending it to alex@contosa.com, and we have something called an operation ID. This is used for tracking it on the event channel on your side. It's just a unique key that you supply, in this case a GUID. So we go and we issue the post to the URL with a payload of our choosing. And we get back a 201 created. So we already know it's a success because it's a HTTP status code between 2 and 300. And we are told that there's a messaging invitation. We're given its URL as a location, which you can see up there.
And you don't see pointing to your screen on the screen,
true, sorry,
so you better use your mouse.
Here it is. Thank you, Albert. I'm just gesturing in the air. Want a laser pointer. Anyway, you have a 201 created. And like we said, for real-time communications, you'll focus on the event channel. So even though you have this URL, it's not really something that you need to worry about so much. We did it more for completeness, and so you have the URL in case you need to track it within your application. But not long after, on the event channel where you've been doing these pending gets, you will get back the messaging invitation that you created. And you see that you know it's yours because the same operation ID that you supplied when you created it is played back for you. So this answers the chicken and egg problem of if you don't know about the resource yet, you don't know its URL or anything about it, how do you know which one is yours? Because you can imagine at the same time that you just created a messaging invitation outgoing, an incoming one shows up. So this is how you track it. Comes back in the event channel. You go ahead and issue the next, a get on the next as we discussed before, and you'll get back a new event response. And now you see that the messaging invitation is now completed, and we see that it was accepted by a specific participant. And if you went ahead and registered an event handler on the messaging invitation, as we spoke about before, your code will go, okay, I now know that it's completed. I will change my UI to reflect that I know now that someone else is listening to IMs. Maybe you weren't allowed to send an IM until you actually know the participant joined. And this is your cue right here in the event channel to make the changes to your UI. Now if you actually want to go ahead and send an IM, where I sent the lookie here, off of the conversation, there is a resource called messaging, which describes the messaging modality in that conversation and what you can do with it. If you are able to send an IM, a link called send message will appear. If you go ahead and issue a post on send message, all you really have to supply is the text that you want, and you'll see the content type here is text plain. And I say hello from the browser, and what comes back is well, it says 200 OK and 201 created here. I know it's a 2XX, and I'm a little jet lagged and can't remember which it is. But you will be told that a messaging resource was created and that the IM is on its way out. If you want to monitor the IM and see if it actually makes it to the other side, you will be able to do that via the event channel. And that is how the IM that we just did, in this case between the browser and between the desktop client, worked. Now, Robert, I turn it over to you for what we sort of already spoke about.
Yeah, so one of the questions, like I said, that we are getting asked all the time is when is coming this or that, etc. And the most important one that we first get asked is, hey, does this API work on Lync Online? And the answer to that actually is at this very moment, not yet. But as you might know, is we are turning on remote PowerShell any moment now. And once you have remote PowerShell, you should, in theory, be able to do the setting of those trusted sites. However, I spoke also about that there are different other things that we need. I spoke about those three things, identity and authentication. You have the signaling, and you've got the media. Now, when we're talking about Lync Online, the one part that is actually different from the Lync server at this very moment is the authentication. So we expect that in due course, but relatively rather sooner than later. So we will be able actually to also provide you with an authentication method that actually allows you to sign in into Lync Online. So start building now, and magically it will start working as well, because we will have essentially the remote PowerShell to define the trusted sites, and there will be an authentication mechanism that is also supported for these type of applications that work against Lync Online. So that's the first question that we very often get asked.
And one other thing for that is, if you still don't quite believe us, remember the mobile clients do work against Lync Online, and they are powered by the API. So the API is already there. It's just, again, not quite ready for public consumption.
Correct, because we are effectively changing the auth a little bit in the Lync Online, or actually in Office 365, because that is the bigger play. But build now, and you will automatically be able to do that now. The second thing that we get asked all the time now, especially because of WebRTC, is when do we get media? And that's a hard one. It's a hard one because of multiple reasons, actually.
How many people here want media right now?
Be able to make a phone call straight from the browser? The media, in order to do that, you need codecs. And in order to have codecs installed, you need to actually be able to install those on the different operating systems. And in order to be able to use them, you need to have an API. And here I effectively have enumerated all the challenges that we are having. The one thing that we do when you are using the Lync web app is we install plugins. And those plugins essentially allow you to, if you look on the web and you do a search for UCWA and namespace and internal and so on, you can see that it is possible, if you do all this tracing that we just explained to you, to figure out. But what you need is essentially be accessing that DLL or that library that essentially does that encoding. And if you figure that one out, you should be able to do that. So what we are thinking now, however, is that the APIs that we have, that we are using ourselves for this media, are actually pretty not developer friendly. So we are considering at this very moment to re-architect that API so that we essentially can make that available. Then coming to the second part, if you would like to actually distribute this on all the different phones. That is actually a very difficult part as well, because if we are doing it in the browser, most of the phone browsers do not allow plugins. Even our modern Windows 8 apps do not allow plugins. So how are we actually going to write libraries for everything? We did write them, but as again, it's a lot of work now to actually make that public. So it is coming. And then the question is, okay, hey, but there is this WebRTC thing. So can't we use essentially the plugins that are provided through this standardization effort? Now, first of all, I need to put a caveat on how far WebRTC is in standardizing, because you essentially need a lot of stuff when you do media. Like, for example, you need to punch holes through firewalls, for example, right? Or you need to do error correction, or you need to do robust type of way of streaming the audio so that you have an acceptable quality. And if you look at the current implementations that are out there, there is not much unity in there yet. Effectively, actually, there's a fundamental discussion going on whether WebRTC is architected the right way at all. At this very moment, if you go to the forums there, to the news list, you will see that there's a whole discussion going on, even among companies, among themselves. Now, the point, however, that I wanted to make is that this UCWA is a signaling protocol. So I have actually seen developers who actually are able to do a mashup of WebRTC, the media component, with the UCWA signaling component, and they are able actually to make a call to the Lync server. Now, if you know about codecs, you know, namely, what are the common denominators. And as I said, it is not video. I have to disappoint you there because the implementations that are out there from Chrome are supporting VP8 and not the H.264 SVC that we are using. However, the common denominator around audio, actually at this very moment, is 711. G711 is actually able to do this. So if you are willing to do a lot of handcrafting of all these handshakes, you actually are able to do, if you wish, you would be able to actually make a mashup of the UCWA signaling and authentication with the media. So that's just, we are working on something that actually makes this life easy, a set of mobile SDKs. We have no time frame to announce at this point in time, but if you want, you actually need to understand what we ever presented in this presentation in order to know that those things are actually very complementary. And with that, that's essentially what is our roadmap. With regards, there will be support in Lync Online or in Office 365, and media, we cannot tell when, but it's on its way one way or another.
All right. So the last thing we're going to do is Q&A and show a little demo if people want to see a bunch of these clients interacting at once. I've just joined a conversation with the iPad. Oops, no, I just turned the iPad off. I've just joined a conversation with the iPad. I'm about to join it from the desktop using the Lync web app, so you can see this API in action with all the features enabled. And I'm also going to join from my phone and put you guys up on screen for a second. So if we go ahead and switch, this is my iPad up on screen. See, that's me. Go ahead and join here from the computer as well. I will switch back to the computer for a moment so you guys can see that happening. Here we go. Go ahead and join this meeting, and I'm going to be an anonymous user now. Go and join. Would you like to use the Elbow plugin so you can have audio and video? Yes, I would. So we'll go ahead and accept. Borrowed a coworker's account for the day, so now it's Albert, Rija, an anonymous person. And now you can see there I am in the browser. If we go ahead, we can go the other way, and we can actually enable video here in the browser. So if I go ahead and do that, you now see this is me on the screen. And if we switch over to the iPad should, in a moment, begin showing. There we go. Switch to the iPad. And now you can see this is me in front of the computer showing up on the iPad. Now we can also go ahead and add another participant to this meeting. I'm going to invite myself on my cell phone. And here it comes. Okay, and I'm in. I'm connecting. Sorry about that. Go ahead and switch. Start my video here. If we go ahead and switch to the other camera, hopefully in a second I'll be able to get you guys to show up here. Hello. Switch to this one.
It's already showing on the other client, on the web client.
Okay,
so maybe
so
you
I'll
switch
switch
to
the
your
web
web
client.
machine.
So if we go ahead, there you guys are. The iPad is only showing 2 people right now. For some reason, it doesn't want to switch to this, I think, because my mic isn't working. But you can see here that we're in on the iPad. We're in on the computer. We're in here. Well, you guys are in here on the phone.
And this is essentially the UC web API, the real-time communications, all using HTTP. And with that, we are at the end of our presentation. As I said, we will be at our booth after this presentation. If you have any urgent questions and want to be here for a few more minutes, we are here. And to any questions. Any questions? Is this a plugin on the mobile device? No, there is no plugin on the mobile device, but we... On the web API? So on the web browser, yes, there are plugins. There's there are multiple installers, one for Firefox and Chrome and one for IE, that essentially are loaded on the first use of that particular, for that particular browser. So in order to get audio and video natively, like I said, there are a few things that you need in your browser as an infrastructure that IE doesn't, for example, have, and that's get user media. That's essentially access to the microphone and to the camera. It's nothing about the codecs. And the second part that you need is the actual encoding. And that's what our plugins do. So those are effectively filling those gaps. It has nothing to do with HTML5 as such. It's a layer on top of it. The get user media is about to be introduced in HTML5, but it's not fully implemented in all browsers yet.
Thanks, everyone.
Thank you. Don't forget to fill out the eval, please. Any other questions?
Yeah. And please follow us to the booth. We're not trying to, it's not that we don't want questions. It's like Albert said, we have a skeleton crew left, so we got to get back there soon.
All right. Thank you very much.